All right, looks like we're live-ish, mostly, partially, maybe entirely. Let's see. Looks like we're live. All right, that's me. So, Ken Wheeler video, yes. Anyway, so the subject of polarization, I just happened to be talking about, and I noticed he had a video on it, and so I thought it was sort of important to talk about it because he calls it a paradox, the simple problem of when you add polarization filters or a third filter, you create more light. I don't know if it's worth going into the details. I suppose might as well try just to explain what is described as some sort of, and it is described as some sort of mystery event when it seems, in my opinion, quite obvious what's happening. And yes, they're missing the obvious, which they tend to do. Uh-oh, wonder what I want here. Yeah, this one. I need to put it someplace else, I guess, so I can, yeah, so I can figure out where it is. All right, I figured out a problem with the weird memory problem. I think I have resolved it. I believe I have. Let me just check the other computer to see if it's still losing hard drive space. No, it is not. So I believe I have. You have to load another program ahead of the other program, and then it works right. So it's really, it must be that the other program was, because it's all public domain, kind of whatever it is, license-wise. So somebody must have redone somebody else's program, and so loading the original program first, the thing actually works right. So it's kind of funny. So there must be some old code in it that fixes the bad code they added. But anyway, I mean, they added some good features, but it fixes the fact that they broke some of the features. But anyway, complicated Linux stuff. Anyway, all right, so this polarization issue is the light goes through the first filter, and so the light's mixed. And most people think polarization has something to do with vertical and horizontal. So there's a shape thing, okay? Light has a shape of some kind, has a property that appears to be a shape, okay? We can say that much as a minimum. And the polarizing filter is kind of known to be a bunch of little tiny lines, is what kind of makes the filter, and microscopic things. And so it sort of fits my jail bar analogy that, okay, so you send in light that is mixed, that is, its polarizations, it could be this way, this way, this way, this way, any polarization can be coming in at any angle, all the way around. And only 50% gets through the filter, depending on which way you're holding the filter. This way, the bar is going this way, or the bar is going this way, or the bar's going this way, or anyway, 50% will get through, which is sort of indicating that the bars are basically saying that any light that is more than a certain degree can't get through. You know, half the light can get through, half can't. So if it's more than a 45-degree angle, let's say they're upright, and it was more than a 45-degree from that upright, it doesn't get through. If it's less than 45, it gets through. And that's sort of the rule. It's probably a little less than 50% that gets through. So that's the other part that has to be understood. But anyway, so the idea is then you put the second filter going, horizontal, so to speak, change the bars to horizontal, and you'll kill whatever light got through, won't get through the second filter. And so the second filter, you'll get 0%. Now, if you stick a third filter in at a 45-degree angle, then you'll go back up to, say, 35%. You'll recover more light by putting another filter in. And it seems the obvious conclusion is that the 45-degree angle filter, putting between the two 90-degree of opposition filter, so you're putting a filter in like this, all it's doing is taking this 50% that got through, and it's allowing essentially a substantial 35% of that light will get through, and it's getting bent by the process. So it went from being vertically polarized to being moved to something in the range of horizontally polarized. 22 degrees, I think, is what it comes down to. So it's an improvement. So the light that got through, so if you understood, the light that goes through originally is mixed. What comes out of the filter is actually light that has been improved in its polarization. That is, it's only going to be very slightly, if anything, off. So the light that gets through is going to be essentially vertical. It's being changed by the filter. And then the second filter is taking that light and bending it another 22 degrees. So most of it can now get through the third filter, because the third filter is a horizontal filter. And so now the light can get through that filter because you've improved its polarization in the direction of the horizontal. So you've changed its polarization. So there's no mystery. All right, hopefully that was an explanation that you could understand. If not, sorry. It's physics, you know. Lots of subjects in physics. And so it's just, you know, I can't cover them all in detail. So anyway, so Ken not only did he made this video, which is garbage, but I mean, he made a 2 or 3 minute video during the day of this video previewing it. Like this was going to be a miraculous explanation of something, and he doesn't explain anything. I mean, it's just horrible nonsense. 21 minutes of saying absolutely nothing but the same jibber jabber he says all the time. Coaxial cable comes up again. I mean, somehow, you know, the coaxial cable just means you have a cable inside of a shielding, and so the current, basically the center is usually positive, and the outside is usually the negative. But it's a cable. It runs from one place to another. How's light like a cable? It's a silly analogy. And when he keeps saying it's not a wave, and it has to be this thing called a perturbation, which is fine. Okay, you want to have a special word for whatever light's doing, but let's just say there's some sort of thing called your ether, your medium, and you're just saying that the light is some kind of pulse that goes through the medium somehow. It pushes along. And we know it does it at a speed, so why wouldn't we call it the speed of the perturbation or the speed of the light? I mean, let's just concede you're not going to change the entire world's vocabulary, and they're not going to start calling light perturbation. They're going to call it light. And it obviously, if you want to say it's a perturbation, fine, you can understand it that way, but obviously it has a speed. So what is this even an argument about? I mean, obviously I could block the light at some other location, and I'll receive it at a different time, and it'll always come out to that C thing, you know, the speed of light. So there's no mystery here. I mean, you really can't contravent. No, sorry again, damn. I got to come up with a better system. Probably. I probably do. I think it's this last one, so I just have to remember where it is. Nope, that ain't it. It's not the last one. It's this last one. Yeah. Yeah, I don't know how to make it stick on top of. Yeah, I could make it stick on top of that, but you know, could make it on top, and then that might be annoying. But we'll see how it goes. Always on top, and then we could just get rid of it like that. That might work. No, this is in the way. Get out of here. We don't need you. All right, so I guess I'll play some of this. Let's see, Ken Wheeler, the king of useless word salad. Yeah, well, it just seems like he gets away with it, though. Quite obviously, people like word salad. 170 likes, 18 dislikes. He's being rewarded for saying absolutely nothing. Apparently, people want metaphysics, not physics. And very few people are complaining, so I figure somebody ought to, so I'm going to complain that this shouldn't be called science or physics or anything like it. It should be called the pseudo bullshit it is, religious rubbish. Just complete bullshit talk, and he should be held accountable. Piece of crap.
It's been the truth throughout the ages, and this is the premise of Platonism. But
I have it up, I have it sped up a little bit. 125, just because, it'd take forever otherwise. So again, he's going to go on this Platonism, blah, blah, blah. So somehow we should go back to antiquity and find out what the truth is. I mean, people who were shitting in their drinking water, we should go back to them and ask them what reality is all about. It's, before a knowledge of evolution, before knowledge of microorganisms, before knowledge of all this stuff, we should go to them to find out what a photon is. Ridiculous.
Pythagoreanism and metaphysics. And that is, if you don't have the primer.
Metaphysics, the primer to metaphysics. And the primer would be what? I love you, Jesus. I mean, what primer do I need? There's these statements that are factual and truthful. They have integrity because there's evidence supporting them. There's statements that are just nonsense and rubbish and have no evidence backing them up. That's all there are. There's no primer. The primer is, I learned what 2 + 2 is. The primer is, I learned that the clouds block certain light because the atoms are of a certain density and they can only be energized by a certain frequency. I mean, the primer is acquiring actual relevant knowledge, not mystical, woo-woo, spiritual bullshit.
And you can't understand anything, kind of like the Rosetta Stone. However, even all ancient Egyptian translations are horrifically inaccurate, but we can transliterate.
Yes, transliterate. I mean, they're really not, the language isn't that complicated in the sense that it's pictures. Some of it, you can figure out when they're cutting somebody's head off that they're not saying, I love Apple Jacks. I mean, you can sort of get the message a little bit.
Them literally. However, when you transliterate something literally.
Transliterate. I mean, is this really a word? I never heard it in my life. Transliterate.
Then it's kind of like giving a hardcore atheist an ancient.
Yes, a hardcore atheist, which means what? An atheist. I mean, there's no such thing as a hardcore atheist. You're either a fairy tale believer in or you're not. I either believe in fairy tales or I think fairy tales are suspect. Very suspect. Until somebody demonstrates one of them to have a grain of truth, I consider them all to be cartoons. There, am I a hardcore atheist now? I believe in evolution, that we evolved on this planet. Do you believe that, Ken, or what? What do you believe? Crazy fuck. Oh, sorry. I'm just so irritated by this crap. These people get away with just spewing bullshit, and they get away with it because fucking idiocracy has taken over. Everybody's a fucking idiot.
Biblical text to translate into English, because absolutely all spirit and character of the text will be
all spirit. So now words have to have spirit. So it's just more absolute nonsense. We can't let there be light. We can't know what that means. I am the word or something. We can't understand that phrase. Yeah, we can. It's not that complicated. Some of their words they fucked up, but I'm just saying it's not that difficult to understand conceptually. The poor will be with you always. Is there some way you can fuck that up?
Be completely lost and transliterated into oblivion, where you end up with essentially text that's like a dead corpse. It's like, well, the entirety of the person is there, brain and spleen, but it's dead. It's not working. So it's not actually alive.
Yeah, it's whatever that means. So why don't you give me some examples? So it'd be really nice if you actually provided examples of where we've transliterated the spirit out of something. So why don't you give me this, do unto others as your others do unto you. Why don't you explain how it's been mistransliterated? And somehow we don't understand that that's supposed to be the concept, that we're supposed to be as nice to each other as we are to ourselves. Gee, have we missed it? Or did we just reject it? Well, what's the truth? People couldn't understand it, or people just said, fuck that, I'm important, you're not?
I have to actually illuminate anybody. And this, of course, is a crude sort of analogy of people that don't actually have the primer to know what a field is or what light is. Certainly.
All right, the primer to know what a field is or what light is. Right, I don't have the jibber jabber, whatever it is, bullshit language you invented. Yeah, I don't have that. Your own little special language, you know, that you invented when you were lonely as a little 4-year-old or something.
The notion of a wave-particle duality is a specious nonsense. First off, Mother Nature has no duality.
Well, it's not specious in a sense. We know exactly where it comes from. It comes from the fact that light does some things that seem paradoxical, strange, bizarre, and it's a very tiny thing, and so therefore we can't investigate very well why it's doing this strange little thing. So they're stuck with a paradox, because a duality, because they just can't nail it down, because we can't stick our little video camera in there and see what the fuck is happening. But the fact that they're satisfied that that's a good enough answer, yeah, that's a joke. I mean, the fact that physics says, I have a complete theory. Yes, I call things virtual, and, you know, I bend non-existent nothings. And yes, I call something both one thing and another. Yeah, that is pretty silly to call that a complete theory.
And a wave is not a thing. A wave is what something does. There's not.
Yes, and that's, everybody calls things. Doesing is a thing, okay? Like running. You know, we call it, we label it. It's perfectly rational. The word wave in the traditional sense is fine. Applying it to things that move in a straight line, like a torpedo, seems kind of silly. I mean, to call a torpedo a wave is kind of like, what are you, silly? Are you crazy? A wave, you know, oh, we'll call the length of the torpedo the wavelength, and we'll call the and it's perpetuating through the, you know, non-existent, never measured ocean.
No such thing as a wave. In principle, as meant a noun. Also, to
again, in principle, as meant as a noun. Who thinks of a wave as a noun? Who on earth ever thought of a wave as a noun? Who sits there and thinks waves just wave? I'm just standing still waving. No, nobody thinks of it like that. Nobody.
Light is certainly not a particle. This is a mishap.
Yes, it's certainly not, and you never prove it why it can't be. You never explain anything. You never draw a simple picture of how it's not possible. For what experiment proves that it can't be? Nothing. Absolutely zero provided as any kind of evidence or argument. Nothing. You just say so, and the little twats, minions, just say, oh, yes, right, Ken, we're good, they're bad. That's all you're doing. You're just preaching a frickin' religion. Us believers are good. Those believers are bad. Christian good, Muslim bad. That's all you're doing. Nothing. You're providing no rationale for your why you're better.
Comprehension of the coaxial nature of light. We actually
coaxial. So again, it goes back to this cable analogy. A coaxial cable is a shielded cable. The, you know, one the electricity is just put through it like any two-wire system. It goes, one wire's the hot wire and one wire's the cold wire. Just like any other circuit, it's like any other extension cord. So to say light's like an extension cord, you know, except the one line is wrapped around the other. So what? How's light anything like that? How? Draw a picture of the coaxial cable running from Alpha Centauri all the way here. Nonsense, just gibberish.
You have transverse electrical, magnetic, and longitudinal pulse perturbations, which are interpreted as...
Yes, okay, longitudinal and pulse perturbations. So somehow, even though there's absolutely no evidence of light ever doing anything sideways, right? There's not a single experiment anywhere that indicates light sends signals sideways that are ever received by anything ever. There's just no evidence of it. The only thing there's evidence of is light landing somewhere. It doesn't spread anything. There's no evidence of a spreading.
Or actually, and I've got a video coming tomorrow about the huge, hardcore, giant hole of the scientific method. People think...
Yeah, so that's probably another silly video. So again, this one big promoted video. He's going to solve a paradox of light and polarization. Has he gotten to the subject yet? No. 2 minutes of crap.
The scientific method is flawless. But the scientific method only revolves around repeatable experiments and.
Yeah, it revolves around the same thing that logic revolves around, okay? So in the sense you have to have some supporting arguments or evidence or facts. And then all you do is combine the facts and look for contradictions. Look for facts that are non-compatible. Like one day it's white and one day it's black. And you say, oh, that's incompatible. We can't say it's white because it was not white on the certain day. That's all. This is not, you're just looking for contradictions. And if there's no contradictions and all the facts point in one way, then you say, that might be a good fact. We'll add that to the facts. Make that an axiom too, until somebody proves otherwise or indicates otherwise.
I'll get into that tomorrow, but if the scientific experiment were anything, it would be a donut with a giant hole right in the center, because descriptions are not explanations.
Again, more nonsense. It's not a description. An experiment is not a description. An experiment is a demonstration. It's right there. It's a demonstration of it happening. It's better than a drawing or an illustration or a simulation. It's a pure demonstration of what you're stating to be a fact. So look at this nonsense. Again, this he abhors, apparently. He thinks evidence is nonsense because that's what the scientific method is. Now, the scientific method isn't being used by physicists at all because they haven't repeated any of these experiments, frankly, any of the important ones. They can't even describe their primer experiments, their basic experiments accurately.
Or repeatable experiments or discoveries, any representation of the accuracy of the explanation of what is going on. Specifically, this is about the polarization paradox. We actually take, and I've got a link below, you can actually take a look at it, or you can type in polarization paradox. We actually take 3 polarizing filters, you place a strong light behind it, and the addition of a third filter. If you actually place the second filter with 90 degrees.
So apparently he doesn't have any polarizing, he only has one, and he only, he doesn't have some polarizing film. He has everything, so I'm surprised he doesn't have that. But this is apparently why he doesn't understand how it works at all, because he's never touched it himself.
Relative to the first filter, you'll end up with something that's essentially completely black. But at the introduction of a third filter, what happens is that the light is greatly illuminated, and people.
It's not greatly illuminated, it's just restored. You get back the half that you lost by putting the completely contrary filter. So you polarize the light this way, and then you stuck a filter and it says only stuff going something this way, right? And so what you need is the third filter in between to move it this way. And now you can get it with the third filter. And if you put more filters in, you can get even more. You can move that number up to 45% instead of 35%.
Misapprehend, number one, what light is, and specifically what a polarization filter is, because there's several different types of filters. There's a cut filter, and then there's a pass filter. A polarization filter is a bit of a cut filter, but a polarization filter is mostly a pass filter, and this is what people don't understand. There's actually all these. It's really funny. There's
really irritating. I want the keyboard to work. It won't. See if it works.
Actually,
okay, it's okay now. All right. So this idea that there's a pass and a block or something is just nonsense. It's always transmission. That's what things do. They're transparent materials. That doesn't mean they're invisible. It means they're transparent. That means they transmit stuff that comes in one side to the other side, and they transmit it by absorbing it and readmitting it. So what a no-pass filter is doing is basically saying it won't accurately transmit certain wavelengths of light because the atoms and the electrons won't permit it. The electrons move and they don't move back. And so the energy isn't restored, so it can't give away a complete photon, so it gives away an infrared one instead, or it moves the atom. And once the atom's moved, for energy conservation reasons, it can't eject the photon or it's losing energy as a system. So there's reasons why certain frequencies pass, certain frequencies don't pass, but they're all being transmitted. And some are just being transmitted inaccurately. Not what goes in doesn't come out. Something else comes out.
A couple of huge videos by these quantum theorists that are actually doing them.
And generally speaking, it's going to be something of lower energy that comes out, obviously. What's being kept inside is movement. The system doesn't give the photon more energy unless you're making X-rays or unless you pump electricity into it. I have a ton of videos on gravitational lensing, so frankly, just type it into my channel. There's 1,000 videos, and I talk about lensing all the time. The last video I talked about it, and you know, but there are videos that go into it in more detail. So, you know, look for a title that says gravitational would be even enough, or lensing. Just search my videos on that title, and you'll have plenty of critiques.
Math calculations, and they show you the triple polarizer paradox. They line up 3 polarizers and a light source behind it. With the introduction of the third filter, it goes from black to much brighter. It's like, wow, by adding a filter, the subject gets a lot brighter, and that actually confuses that.
So he doesn't explain any of why that is. So he did this whole video, and he provides no explanation. His explanation is basically the light was still there, and the third filter somehow undoes the interference that was blocking it. So it uninterferes the light so you can see it again. That's his explanation.
A lot of people, but it only confuses people because people don't understand what a polarization filter is, but primarily the reasoning for the misapprehension is that they don't actually understand what the hell light is.
Well, why don't you explain it then? Why don't you explain what polarization is? What does a photon appear to be? How is it? How does it perturbate? Why can't you draw a picture of any of this to explain what polarization is and what the polarization filter is doing? I mean, you give nothing.
It's not a particle, and it's not a wave. And quantum specifically actually refers to nothing in denotation.
Well, it is in fact a particle in the sense that it fits all of the characteristics of a particle. It's a discrete corpuscle. It's a little bit that travels through space at a certain speed, and it impacts things as just a little bit hitting them. It's a little package of momentum. That's close enough to the definition of a particle, I think.
Quantum is a BS term used in various countless branches of science that actually doesn't represent anything.
Yes, all kinds of things are called things that don't mean anything. Like you're called a wheeler, a Ken Wheeler. Does it mean anything? No, but it's a label. It works. Quantum is a label for a concept, all right? And the concept is kind of connected to what's called quantum mechanics in the sense that it's an effort to quantize the fact, and it's a recognition that the evidence indicates that energy comes in packets, in perturbations, if you want to call them that. It comes in discrete perturbations. That's what quantum essentially means. And so this complaining about the stupid word is just a waste of frickin' time. Everybody, the word is meaningless. It's understanding what the science is. It doesn't matter what they call it, just as it doesn't matter whether you call it a photon or a coaxial perturbation. What's the difference as long as we understand what the evidence indicates the thing is?
Hardcore original classical field theory. I mean, the entire 100% of the electrical grid on the entire Earth is based upon the discoveries, inventions, and writings of Faraday, Steinmetz, Nikola Tesla, Oliver Heaviside.
Right. I mean, let's just point out Tesla wasted millions of dollars in his day trying to shoot lightning to France. You know, I mean, who would think you could do that? Even if you could get lightning to fly straight, which doesn't make any sense because the ground is right there and it wants to go to it. How do you think it's going to get through all that atmosphere and survive? Where do you think all that light is shooting off of it for? Well, that's all waste. You know, horrible waste, tremendous amounts of waste. That's an indication of a tremendous amount of heat. How could anyone possibly think it was possible? All right, and the rest of the guys, they all did their little bits in science. But again, this idea, let's go back to the past. Let's go back to when they were ignorant. And they were. A ton of experiments hadn't been conducted yet. A ton of things hadn't been discovered yet. So let's go back to the ignorant and ask them what the truth is. How does that make sense to anybody?
James Clerk Maxwell, and these people had nothing to do with quantum BS.
Yes, and if they existed today, do you think they would agree with you, Ken Wheeler? Do you really think that? Do you really believe that if these people existed today and had access to all the experiments that have been conducted up till this date, do you really think they would sit there and say, oh yeah, Ken Wheeler's got it? You really think so? He's talking the truth. No, you're an archaic propagandist, a propagandist for archaic notions of reality, silly religious Thor kind of notions of the truth.
But that's a matter for another video, of which I've made countless such videos on the BS of quantum.
Yes, and they're all the same video, saying the same crap, never demonstrating anything with anything called evidence or honesty. Okay, and I'm going to call you very dishonest because I think Ken Wheeler knows the truth about the Pharaoh cell, right? So I had a couple of questions I thought would be worthy of asking him. Does the solar cell, that he made, where he uses solar light, did you put holes in it, just like LEDs? Because you knew it wouldn't work if you let light just go in, right? It has to be directed light, or the illusion doesn't exist. Your little lines don't get created, right? Is that the truth, Ken? That you had to duplicate the LED with the solar energy. And I'm sure you've done it because he's made lots of solar cells. I'm sure he's made a cell where he put maybe 4 LEDs on it. And he saw quite clearly that, oh yeah, I only get 4 lines. All the magic sort of disappears when there's not enough LEDs. I'm sure he's done that. Why don't you explain that? Why don't you say what you've seen? Honestly, when you've played and tinkered with these things, you just sell it. Again, you quote mine reality. The facts that the experiments that are supportive of your nonsense, you'll talk about. The ones that you've no doubt done that don't support your nonsense, you don't say nothing about that.
I've also made a countless number of videos on light, which you can look up, and I'll continue to make a lot.
Yes, and you say nothing. Coaxial cable perturbating. Okay, whatever that means. It's impossible to visualize any such notion.
More videos on light because humanity certainly doesn't understand what the hell light is. And they think it's a particle in a way. Well, it acts like a particle, it's like this, and it acts like a wave like that. Well, once again, there's no such thing as a wave. And
it always ends up as a corpuscle. I think Feynman would kind of say that. Regardless of nonsense you want to think it is, it doesn't matter. It always ends up as a corpuscle, as a little blob, as a clump, as a lump. That's what it ends up as. That's what it's always detected as.
Light is certainly not a particle. It's a misapprehension of a coaxial circuit, and also too
it's a misapprehension. I certainly understand what a coaxial circuit is. I've used them. So I'm just saying how, first off, what are you sending through the middle and what's coming back through the other end? And where's it going back to? The sun that produced the photon could blow up by the time the photon gets back, right? I mean, how's it still perturbating if the sun that originated it blew up? I mean, we're seeing light from things that are long dead. If the coaxial cable is connected to the thing that sent it, how's the thing still functioning? How's the circuit? He calls it a circuit. How's the circuit still functioning?
Pulse perturbation, rarefaction, and compressions.
Rarefaction and compression. Okay, that's a wave. Okay, compression and expansion is waves. Just to let you know, Ken. That's a property of waves, compression and expansion. Okay, so you want to say a compression and expansion is somehow, what, is it moving this way through space, or is it compressing and refracting this way and then moving through space, or what? How exactly is your little blob of whatever magic putty exactly perturbating through space? Why don't you draw a picture
of the longitudinal field perturbation, which actually makes up light, which is a coaxial circuit. Most people don't know what a coax. I think most people don't know what the inside of a coax cable looks like, but it's a coaxial circuit.
Yeah, it's a circuit is the key point there, right? Circuit to what? Tied to what? What's it a circuit to? Again, if I disconnect an electrical magnet from a battery, there's no more magnetism. The magnetism doesn't keep moving until it runs out or something. It just stops. It's done. No more pressure, no more happening. So if your sun blows up and your light's 4 billion years on its way and it's going to go another 4 billion years, and the circuit blew up already, the battery's dead, how's your light still perturbate?
Look up what a coax, inside of a coax cable looks like. No, it's interesting.
Look up what bullshit looks like. Go type bullshit into Google and see what it looks like, because you're just talking bullshit.
Interesting type of coax cable, by the way, is called a air coax. It's just the type of coax that feeds $1 million TV.
Who cares? I mean, again, more just absolute nonsense. You know, just rubbish. Yes, they use all kinds of ways to filter, okay, you know, and that's what coaxial cables are intended to do. You have the ground, okay, the negative pole, wrap around the positive pole, and the idea is that negative ground will absorb any radiation that might attempt to hit the positive pole and cause noise. So it's a way of cleaning keeping the signal clean, keeping the electric line clean from external noise. No big surprise that big radio towers would create a coaxial cable that could carry high amounts of amperage. So that's why they make it out of metal tubes.
Stations with tremendous amounts of power, and what they are is two hollow copper tubes that are actually suspended from one another using spiral plastic dielectric, which actually just keep
an insulator. Nothing complicated there. Just like a coaxial cable has an insulator in it. But obviously, the higher the voltage you're using, the better the insulator needs to be.
Keeps them separate. They may do nothing other than keep them separate, but that's a matter for another discussion. The actual nature of the most efficient coax on Earth is the fact that the center of the ultra-high power, ultra-efficient coax is...
It's really not for ultra-high power and blah, 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 blah. Most coax is not high power. It's low noise. It's just intended to eliminate noise.
Has nothing in the center. Is literally air. They call it an air coax because the copper tubes, one inside the other, smaller one inside the larger one.
Yes, because air is a pretty good insulator. Yes.
One contain
not as good as a vacuum, but good enough.
Nothing. They're air. They're just hollow tubes. But that's a matter for discussion of field theory. Anyway, the answer to the
right. So he hasn't gotten anywhere near this polarization subject. So we're 9 minutes into 5 minutes, 6 minutes into this thing. He hasn't said anything about polarization, what the fuck it is or how it happens.
The polarization paradox is that people need to understand first off, before we get into the discussion of light, and I made countless videos on light, is that a cut filter versus a pass filter. What is an example of a cut filter? Cut filter is, especially probably a lot of photography people are watching me, is that like a red filter, a blue filter, green, whatever color the hell the filter is. If you add more and more on it, it gets darker and darker and darker.
Again, there's no such distinction. There's just transmission. And some things will filter for different transmission elements. But that's all there is. There's no such thing as a pass and a cut. No such thing.
Darker, right? You add a red filter to a blue filter and a green filter and then a puke filter. Whatever the color that is, you end up with a diminution or a cutting of the light. And that is the case to a very slight degree from a polarizer, because if you hold the polarizer up to any light source, you end up with less light. But that's the reason that it's actually cutting out a certain pass.
Yeah, no, it's cutting out half the light in a normal circumstance. Obviously, in the circumstance of glare, it's cutting out 90% of the light. So if you put it in front of a glare where the light is polarized, it'll block the whole thing for you because the glare is always coming in a certain direction. I mean, turn the glasses sideways and all of a sudden they don't work anymore. Okay, and the glare will get you right in the eye. So it's because we know that glare comes off in this way, then you're, so just turn your head sideways and you'll get the glare through the polarizing glasses. But again, it's obviously not transmitting certain light. And so a polarizing filter is blocking based on polarization, and a color filter is blocking based on frequency. But this garbage that this has, like I said, you can create a filter that just blocks half the light, just by putting opaque bits inside of the substance and say, there, I blocked half the light. Yes, You haven't transmitted it. But color filters don't work that way. Color filters transmit all, or essentially as much as possible, of the non-blocked light. So they're clearly pass filters.
Polarization of the light that's passing through the filter, but that doesn't mean it's a cut filter. It means that it's actually a pass filter. Well, it is also a cut filter because the light is diminished. No, the reason the light is diminished, and it's only being diminished because the transverse component, or one axis, and this.
Okay, it's only being diminished because the transverse component. So he buys into this idea that there's two components to a photon, you know, that it's doing electro and it's doing magnetico. And so he's saying something, one of them is being blocked by the polarizing filter. And that somehow when you put the other filter in, you're restoring the magneto or the transmitto or the whatever, the electro or the magneto.
Again, it's about comprehending the right-hand rule. One aspect of the light is being cut due to the fact that, and it is by definition, a polarization filter is being cut by the filter. But it's not.
So he's not telling us what aspect of the light. So how exactly it's doing that. How's it cutting the electro, or how's it cutting the magno? How's it doing the cutting?
Actually cutting the light. It's actually eliminating out. It's a diminution of the manifestation of light. But
so a diminution of the manifestation of light. And then later he'll say, no, the light went right through the filter. It just got interfered with. So it was light plus light equals dark. And when you put the other filter in, you've restored the dark back to light plus light. That's essentially his argument 10 minutes from now. So now he says it's a diminishment. The light was destroyed. Later he says, no, it wasn't destroyed at all. All it was interfered with, and now you just uninterfere it and everything's fine. I mean, he contradicts himself, says 2 different stories, 3 different stories, 5 different stories. He just changes the story throughout the video, and again, gets colossally rewarded for talking absolute nonsense. That no reasonable person, in my opinion, could listen to this gibberish. As a 10-year-old, I could listen to this and say, what the fuck is this idiot talking about? A 10-year-old can say, this isn't a rational description. If somebody tells me they saw a car and they could draw me a picture of what they saw, why can't you draw me a picture of what you think this mechanics works like?
The filter is only causing the polarization of one particular, depending on whether the electrical or the magnetic, it doesn't make any difference.
They can't have opposite polarizations. Obviously, they're perpendicular fields, so they can't be oppositely. They're always going to move together. So if one's vertical, one has to be horizontal. It's the way the rules are. So you want to change those two and pretend that you can push the magnetic field into the electric field, and they can both be on the same polarization, which they can't. So even by conventional nonsense theory, which he's accepting, which is funny, you can't do that, Ken.
Degrees relative to the passing light that's actually going through it is being cut. So it's a cut filter is what I'm trying to get to without getting into a long description, as opposed to, it's a pass filter, excuse me, rather than a cut filter. But ultimately, the observation is that a polarization is cutting the light. A polarization filter is cutting the light.
So he says it's a pass filter, and then he says it's cutting the light. I mean, again, this is supposed to hit your brain and say what? Bullshit. I mean, what do you mean? It's a pass filter, but it cut the light. What is that? But gibberish.
But it's only appearing that it's cutting the light, and this is.
It only appears like it cut the light, so it didn't really cut the light. So he says it cut the light. It's clear it cut the light, but it didn't really cut the light. It just appears like it. So appearances mean nothing. It has nothing to do with it. So I shouldn't even bring up what it looks like, because that has nothing to do with what it actually is. So when I say it looks like a coaxial cable, that doesn't mean any shit. Yeah, fuck that. It's just nonsense. Don't pay any attention to what I'm saying. Nothing looks like what it looks like.
Really important because it's actually a pass filter. And that's important to understanding what's going on. Light is a coaxial circuit, as already mentioned. The coaxial circuit of light, the perturbation is longitudinal. Only the transverse components, which are the...
So, it's, yes, of course it's longitudinal. It moves in a direction. Yeah, okay, we all get that part. But then with this transversy part, where's the evidence of the transversing thing happening? Where's the transverse part ever indicated in any experiment in the history of mankind? Where's the transverse part happening?
Expressions of the pulse perturbation of the nature of light are affected by the polarization filter.
Whatever that means. So the polarization filter affects some kind of perturbation. Okay. So, like, again, we know how we made polarization filters. I mean, we know what they are. We know they're lines, essentially, of changes in material. And we know that when you change transition between like glass and water and air. They all have a different refractive index. There's the transition between two substances is always a weird location. So they have this little transition created, little transition zones that the light has to go through. And it's going through those transition zones where this phenomenon of polarization being changed or blocked happens. That seems to me a foundation. You have to start with that foundation. You can't just pretend those aren't facts. Pretend that the lines in the polarizing filter don't have anything to do with anything. They clearly have something to do with something. They're clearly a part of this story, an important part.
And are the remanifest given additive conditions which are made appear and made manifest when you actually introduce the third filter? If you can actually check out the video over here. Or you can take 3 polarization filters and hold them up and introduce a third filter between the two, and you'll actually see that the light actually increases.
Right, and the third filter is at a 45-degree angle to both of the other filters. The other filters are X, and the other one is cutting it in half. And by doing that, turning the light incrementally so it can go through both filters.
Which is counterintuitive to what people understand a filter to be. Well, yeah, but they're thinking in terms of like a color filter, which is a cutting filter. But this is not a cutting.
So again, it's just this argument that conventional science can't get right because they still don't understand that their measuring tools are influencing tools. And it just seems quite obvious that the tool that's measuring for testing for polarization is also altering polarization. And that's all that's happening here. No great mystery. The polarization is being altered by the filter. Enhanced, you could say, in a sense. It's being improved. Okay. The filter makes it more like itself. So whatever the filter is, the light's going to come out very much like the filter. So it went in a little less than filter, not quite like the filter, but close enough. And it comes out much closer. Doesn't work. Space bar just won't do it.
However, the observed effects are that it's cutting the light to a certain degree, and even more so if you orientate it correctly. Like, you point this out at like a shimmering lake waters, or you point it at a sky, and make the sky bluer. Most everybody, at least everybody in photography, knows what a polarization filter does, but it's a pass filter. So the second filter is 90 degrees to the 90 degrees relative to the first filter. I have a second filter back here, and
right. So that's correct. Yeah, but once again, this pass filter, they're all transmission filters. That's all. So if you want to be accurate, use accurate language. They all are transmission filters. That's it. And they transmit some things truly, and they don't transmit other things truly or accurately or the same. They change them. And they'll change them into some invisible radiation, usually at a lower energy or a lower frequency.
Orientation is made 90 degrees to the first filter. You basically have zero light that is passing to your eye from the second filter, but this is incorrect. The perturbation is still present. But
okay, so the perturbation is still present. So somehow the light really did get through, but it lost part of its coaxial cable. I mean, how exactly does it get through but doesn't get through? So again, no explanation for how this happens.
It's longitudinal. The transverse component is actually filtered out the manifestation of that light, but the perturbation is still present.
So the transverse portion is traditionally drawn as the magnetic portion, but let's just say it's the electric portion. It has to be either the magnetic portion or the electric portion. So you're going to strip some part of the photon's identity off, and it goes through as still being something, some kind of perturbation, some kind of the same. It somehow still has its sameness to it. And somehow by putting another filter in, it's going to put the stuff back on. That seems like a conservation of energy problem, how one thing can strip something off of an energetic perturbation, and then some other thing can put the energy back on.
Present. People understand everything is capacitance, resistance, permeability, and permittivity. What you
Yeah, it's more nonsense. Capacitance, resistance, permittivity, permeability. These aren't rational words that mean anything to people. And again, how does light a capacitance issue? What do you mean? What are you talking about?
think you're seeing as the absence of light where secondary filter is brought 90 degrees relative to the first, and everything becomes completely black. But the introduction of the third filter between the two actually remanifests the light. Well, it doesn't remanifest the light.
Okay, he'll do this over and over. It manifests the light. It doesn't manifest the light. Of course it manifests the light. Yes, it restores the light. And no, it doesn't restore the light. It's more bullshit.
Because the light was always there. And people need to understand that
the light was always there, but it wasn't there. Obviously, it was blocked by the filter, so how could it always be there?
Distinction between light and illumination. Everything we can...
Light and illumination, some more nonsense, right? I mean, obviously we know the difference. One is where the light is going to what it's going to illuminate. Kind of obviously what it's going to reflect off of and then bounce into my eye. So I mean, illumination is it bounced off of something. I'm sorry. I mean, I don't know how else to interpret it. There's light that's going someplace. I don't see that. I see it when it gets somewhere, bounces off of it, and goes in the little hole in my eye.
Considered to be light is actually illumination, because, like, this is the...
It's not illumination when it's not hitting anything. So this is just more nonsense. I can stop the illumination of something in the universe by just sticking this in the way. All of a sudden, it's not illuminating me anymore. It's illuminating something else that's in the way. So we kind of know that light's not illuminating until it hits something. It has to bounce off something before it can illuminate it. Illumination is a specific thing. That is, it's a reflection, clearly. You can't have illumination without reflection. So if something absorbs the light, that is, the light goes in, creates infrared, gets warm, like a piece of black paint. I could paint something black and stick it out in the sun. The illumination doesn't reflect. Instead, it just heats up the black paint. Very different thing, illumination and non-illumination.
The thought experiment that I've given you countless times before in the case of the invisible man. An invisible man would be completely blind. If there could...
It's just an idiotic concept, right? The invisible man would be completely blind because there's nothing for the light to reflect off, in terms of nothing for it to hit inside his retina. Yeah, well, obviously he wouldn't have a stomach either. He wouldn't have a liver, wouldn't have any organs, wouldn't have anything. His heart couldn't beat because it didn't exist. There can't be blood in it. There can't, obviously. But that's not what being an invisible man means. Being an invisible man means somehow you're transmitting the light through you, right? So the light that you're not seeing, so the little tiny bit where his eyes are, the little tiny hole would be the only part you necessarily would have to see. So he's completely invisible except for that little frickin' hole where the light's being absorbed. That is, absorbed and not transmitted.
Be such a thing like the Fantastic Four, right? Of an invisible man or an invisible woman, whatever the case, they would never see light, because if someone is completely transparent or invisible, then there is no capacitance, resistance. Specifically, there's no magnetic permeability or dielectric permittivity.
And just complete nonsense, right? I mean, I could build, they've already done it. They've built clothes that basically transmit an image to the other side. So technically the light comes in one side and they emit the same light on the back side. So the thing ends up looking pretty much transparent. All right. I mean, it's a gimmick. It's not very good. But obviously with technology that could be made better. And clearly the person wearing the clothes, quote unquote, would still be alive.
For light to become manifest on the back of the eyeball of an invisible person. But this is a thought experiment that gets people's minds thinking about the nature of light. But also, too, you have to differentiate out light from illumination, but that requires a lot.
Again, more nonsense. You have to differentiate light from illumination. It's just, there's no way to have illumination without the light. The light is traveling to make the illumination. It has to travel from the thing illuminated to me to be illuminated in any meaningful way where you could measure the illumination. What's complicated about this? Why would anybody have a problem understanding that they The light isn't illuminating something until it actually gets to it and then reflects off of it and gets back to them. I mean, I think people understand that their image bounces off the mirror and then bounces back to them. The same idea. That's illumination. They understand that. What's so complicated?
Out of other lengthy videos, which I've already made. And the second filter is completely destructive because it's brought 90 degrees relative to the first. The third filter is completely constructive and sets up an interference pattern with the perturbation to remanifest the light.
Okay, it sets up an interference pattern to remanifest the light. I mean, how does interference remanifest? I mean, it really doesn't work that way. It moves light, or it destroys it. Wave interference. Waves get tired.
Because everything is constructive and destructive interference, as in the case of light.
So again, he's using a wave analogy when he says it's not a wave. So, how does that make any sense? How can you have constructive and destructive interference if there's no waves? The whole concept is based on this spreading wave thing. So he's using wave terminology, wave functionality, and then claiming it's not a wave, it's a perturbation. So how does the coaxial cables interfere with each other? Why don't you explain that? Show me, draw a picture of the coaxial cables interfering with each other. Let's see. If you feel inclined, what is your stance on time? It's a function. It is not a place. It is not a dimension. Time only exists because light doesn't move instantaneously fast. So as soon as you have something slow in the universe, you have time. Fuck. Not at all complicated. Time is a byproduct of moving distance. Period. Nothing more. Oh, I don't know why you need to put magic wheels on time.
It's the same reason when we see that particular hypertrochoid pattern on the ferrocell, i.e. the supercell. That pattern is due to the constructive and destructive interference of the divergent and convergent magnetism, actually centripetal.
So somehow the magnetism, as I've now illustrated, microscopically you cannot find any of those patterns in the ferrofluid at all. It's clear by rational observation that the light does a specific thing. That is, it reflects off the flat surfaces, the long surfaces of the ferro bits. And it does so by very strict rules. And that's what's creating the optical effect. And it has nothing to do with any kind of display of the magnetic field. It has to do with a complete distortion of the magnetic field's appearance, because you're seeing things based on their angle, not their linear, not where they actually came from, not representing the actual structure of the ferro material at all. It's an illusion, a delusion. It's deceptive. You're just seeing a deceptive image. That's it.
Convergence and centrifugal divergence. We have the force of motion, inertia, and acceleration between the dielectric and the magnetic, and we end up with this light pattern.
So anyway, all this dielectric, there's no dielectric anywhere in a ferrocell. There's none of this crap is happening. This more made up bullshit.
And this light pattern is due strictly to the constructive and destructive interference between the dielectric and the magnetic.
So again, it will be completely demonstrated eventually. I guess I'll have to be by me, but there's clearly no evidence of any of that, and there's clear evidence that the effect is completely an optical illusion. That is, it's a distortion of reality. It's not showing you reality. It's pulling rabbits out of hats and pigeons out of sleeves. You don't see the reality. The pigeon was there all day. It wasn't manufactured.
All of it is just simply the magnetic pattern, which actually interferes with the light that's passing over top of the magnetic field.
So again, it has nothing to do with light passing over any magnetic field. It has to do with light reflecting off little bits of ferro material.
Field. Also, too, we have to, and I have to do that in another video, actually define propagation, transmission, induction, movement, and perturbation. Or in this.
Yes, well, I think we all know what movement is. Some of those words are perfectly rational, and yet you never use those words. You just keep saying perturbation and coaxial cable and not explaining at all what one of these things actually is. Is it a torpedo? Perturbating? What is it? What perturbates?
In this case, further still definement of perturbation in the terms of disturbance. Field.
There you go. Yes, disturbance, a perfectly rational word. So let's just use a disturbance in a ether. So you vibrated the jello, and the vibration moves through the jello. And so go with that. But again, explain how that isn't exactly the same thing, technically, as making energy. You have to create energy to vibrate jello. You have to put in energy to get energy to perturbate. So again, you're back to the question, where does the energy come from? How are your magnets perturbating the field? Where are they getting the rocket engines from? What fuel are they burning?
Perturbations and propagations, but fields are not transmissive or move.
So they don't transmit. So a perturbation isn't a transmission. You know, there's just nothing here. There's nothing. He says it's not tall, it's not short, it's not fat, it's not thin. It's not nothing. It's nothing. It's rubbish. It's not a description of a physics. It's description of woo. It's a magical thing. It's not a thing. It's magic. And that's all there is here. It's just magic talk, fairy talk, pixie talk, gremlin talk, mushy religion.
Let me restate that. No field ever moves, nor is transmitted. Well, sure, cell phones transmit signals, and I'm used to be a ham radio operator. Ham radio antennas transmit. That's not the case. The correct understanding of the nature of fields, and this is the understanding also.
So it isn't rational just to call it transmission when the perturbation, the energy, the effect travels from one thing to another thing. We can't use the word transmission for that. That's being stupid. That's being a knuckle dragger.
Of Tesla and Walter Russell and a very, very few others is that fields have nothing to do with transmission or movement. They have to do with perturbation and propagation, and this is as...
Yeah, exactly. If you're going to create an ether, I'll grant you there's no point in sending material things through it to get stuck in the friction. So yes, if we're going to make an ether, yes, let's just vibrate it. Okay, if we can get away with that, fine. But then you have to explain how the vibration travels exactly like a torpedo, because nothing in the universe appears to be able to do that.
For a medium. In the case of the coaxial circuit, the polarizer is not a cutting filter, as I said, it's a pass filter. And
so again, I'll re-emphasize, they're all transmission filters. And the key word is filter. So they filter what they transmit. They transmit some things accurately, some things don't get transmitted accurately. Period. No more, there's nothing else involved. You either transmit it or you don't.
So a transverse right-hand rule gateway. So
more, he just throws the right-hand rule in there, like, you know, somehow we have to worry about which way it's spinning or something, and it's following the right-hand rule, which means it's electrically going this way. So I guess it can't lose its electrical, because it has to be, that's the only thing that could be right-hand ruling is the electrical part.
And I don't know if people understand, maybe they do, I think I'm completely defining the huge difference between a cut filter and a pass filter.
Again, no such difference. He's not drawing a picture of this difference. The key ingredient, again, is the conservation of energy. So regardless of what it's doing, it's clearly either absorbing or translating. That's not the word I want. You know, changing. So it's either going to reflect the energy, convert it into motion of the atoms, are converted into infrared, but it has to come out as something. There has to be a product. The energy has to be conserved. But that's all there are. There's no, this distinction of pass and cut is just nonsense.
Actually, I wanted to mention something else about the polarizer and the polarizer paradox. It also goes by a couple other different names. Polarizer paradox is...
See, the whole video is supposed to explain that, and there's just nothing in this video, right? There has been no explanation of either what polarization is or how the filter filters for it. No explanation at all.
The one that I grew up with. I had a lot of people ask me
That reminds me, this shirt is 40 years old. Yeah, I used to wear this when I was a bartender. Yeah. Anyway, quick question. In your revival of mock gravity, I'm not reviving mock gravity, so I fuck you for the idiotic premise. Wouldn't gravity be proportional to the area, not mass? Of course not. Gravity is always related to mass. Mass is what absorbs gravity, just like mass is what absorbs photons. It has to be made of electrons and protons, and neutrons are just electrons and protons. And that's what's absorbing the gravity. Nothing else can absorb it. That's it. Electrons, protons. That's it. Mass. The end. The only thing that matters. Again, you're not understanding. Obviously, mock gravity can use, because it doesn't have to fit into the rest of the universe, it can use the idea of stuff bouncing off of stuff. So I can use the BB example, where you just have a bunch of energetic BBs in a box, and then you put two things in the box, and the two things will be pushed into each other. Yeah, they're being pushed in by mechanical impacts, and lots of velocity degrades and lots of things are happening, but it still works. The point is that if you want to make it into something that's more useful as an explanation of actual gravity, you have to account for lots of other things. And the real truth is gravity is an absorption of energy. It is not pure reflection in any notion of reflection in the sense that something bounces off and then bounces off and there's no energy imposed on the thing. It's clearly an exchange of energy. Something comes in going this way. The thing absorbs the energy, and this is given back. Equal but opposite reaction. So if you're going to absorb something this way, you have to give something back. You have to give this way back to balance the equation, to create conservation. So it's an absorption of a direction. So again, I'm not reviving mock gravity. I didn't even know what mock gravity was when I came up with my theory. Never heard of Lesage, never heard of mock gravity, didn't know anything about that stuff.
To explain the polarizer paradox, now like I said, first it understands the nature of light. That has to be understood. Then you have to understand the difference between a cut filter and a pass filter. Polarizers.
So he says it again and again and again and again, as he usually does, just keeps repeating as if this is the important thing. As I've just explained, it can't possibly be important. It has nothing to do with polarization. It's, you don't need to understand the difference between a cut filter and a pass filter when you know the polarization filter must be a pass filter because it's passing half the light automatically. And it would pass all the light if it's polarized the right way, and it block all the light if it's polarized the wrong way. That's why polarizing glasses work. They block the light going the wrong way. That is, all the light that's coming in from glare gets blocked because it's all going this way, and your glasses are lined up this way. I mean, you don't need to know what a cut filter is to understand that's what this filter is doing. It's letting stuff that's one way get through, and it's blocking stuff this way, and stuff this way gets through and gets improved to this.
Don't absorb, as they say. It was, well, this is absorbing light. If you turn it, leave it absorb more light. If you stick another filter behind it, 90 degrees relative to the first, it's absorbing all the light. They're not absorbing light. It's rather the subtractive luminal perturbation through destructive interference. Let me repeat that again, because that sounds convoluted. And
all right. Well, the gravity is a different subject. I mean, I'm really doing this polarization thing right now in light. So, but okay, I'll answer your question. All right. Sorry for my poor phrasing. How do the force bits get absorbed by the atoms that are much deeper into the Earth? Obviously, the pressure is what they're dealing with, chemical pressure. So the force is basically in the fact that the atoms are being smashed together, and that means it's like ping pong paddles, right? Two ping pong paddles, you move them closer together and you have a ball bouncing between them, it's going to hit more often, more energy. So just moving things together creates, in a sense, more energy. You've made more impacts. So the pressure is being transmitted through atomic pressure, and atomic pressure is really the same thing. It's just electrons with little bits bouncing between them. So it's essentially the same force. You're just compressing the force into smaller and smaller confines, which means it's more energetic. So that's how the gravity is transmitted, in a sense. It's absorbed on the outside as gravity, and it's transmitted to the inside as atomic pressure, pushing by creating more force heading in that direction. Wouldn't they be mostly shielded by the atoms near the surface? Well, it's pretty much impossible to shield it, right? I mean, these force bits, or the photons, the gravitons, are inside every atom. So when you bring a force bit out here, it's going to go through all the electrons, just like electricity passes through a wire. There's no congestion or big problem. It just pushes one electron into another. And when you push one electron towards another, it's the force that pushes this electron. The electrons don't hit each other. They push on each other with force. So the force pushes, and that force pushes, and that force pushes, and that force pushes. It transmits the force. So the force goes in one end, and it just travels right through all the atoms. Okay. Oh, that makes sense. Good. Okay, so we'll move on back to Ken and his bullshit.
It's actually not. It's subtractive luminal perturbation through destructive interference. Really?
So again, destructive interference. He's not going to draw me a picture of the interference, the destruction, how the coaxial cables destruct with each other, how they do any of this crap. Nothing.
No different than like the supercell over there, where you could actually, the introduction of another magnet, you can completely disappear or vanish out the light, but the light is still present there.
The light is still present there, except it's not there. It's not coming out. It's not there. You can't detect it. It's not there, but it's still there. I mean, does that make sense to you people, really? Conservation of energy and everything. You really think photon plus photon equals no photon? You really think that's possible? You don't think the photon must go someplace else? Oh, God damn.
You have nearly complete destructive interference. Nearly complete. But the destructive
nearly complete, but not complete. What do you mean not complete? It's 50-50 filter, essentially, right? I mean, obviously, I'm arguing it's not, but, exactly 50-50. But, what is this argument? Complete, not complete. Clearly, the light going the wrong way doesn't get through.
Interference, and this is the key point that everybody's missing. The destructive interference, where you can basically see no light with the two filters present, correctly positioned where you see no light, is not the emission of light. You have complete destruction, but not the.
You have complete destruction, but not the emission. But the emission is still the emission, even though the destruction was the destruction. The emission was the emission. So you can never undo the emission with a destruction. So emissions always rule destructions. Something like that.
Deletion of the longitudinal pulse perturbation, which actually.
So it deleted the pulse perturbation, but it didn't hurt the magnitude of the photon at all. Even though it was deleted, it's still on the hard drive somewhere. Since it's a coaxial cable, you can't make a coaxial cable disappear.
It makes up the coaxial nature of light. So the light is still present in the form of the perturbation, which we refer to as...
It's still present as a perturbation. It's just a perturbation that's not got any presentness. So it's still present. It just doesn't have any presentness. I mean, how is this not completely mockable nonsense? And every one of the idiots who would thumb up this frickin' babble. I mean, if somebody was to explain how to put your garbage can on the street using this nonsense language, well, you walk up to the street. Well, you don't really walk. You perturbate. And then but you have to have the can with you. But I know the can's heavy, so who wants to carry the can? So maybe you could interfere with yourself and, maybe let the other one of you, the one you interfered with, carry the can, and then you can walk freely without having to carry the can because your entangled partner can carry the can. And then you get to would they buy this crap? No.
illumination, because light doesn't move. It's actually a rate of induction. Eric Dollard.
Yeah, who cares? I mean, what the fuck is the difference? The rate of induction versus the rate of movement. How is the two things any different? How is the different? The perturbation has to go from one place to another place, and it takes time to do that. How the fuck isn't that moving?
Said this, and famously Walter Russell said this, and superficially that seems incredibly foolish and stupid, but there's actually only one way to actually correctly explain all the phenomena that we know of light, like it's slowing down, so to say, 30% as it enters glass. That depends.
It's 50%, but whatever. It doesn't slow down. And even if you're going to argue that somehow it's being retarded in its progress by syrup or some kind of thickener, obviously when it got out of the thickener, it would go back to its normal speed. So, I mean, if you're going 50 miles an hour and you have to plow through some water or something, and it's slowing your velocity down, if your velocity is being maintained by engine speed, then as soon as you're past the water, you go back to 50 miles an hour, no problem. You didn't put your foot on the pedal any harder.
On what the glass is made out of, obviously, and then, quote, speeding back up again after it leaves glass. And that's actually impossible to do.
Right. Nobody would say this. I mean, again, I've never seen a physicist really talk about glass light speeding back up again. It doesn't have to re-speed. Like I said, even the ones who think it's being retarded as it passes through the glass by some sort of ether or thickener, who don't understand that it's just a path length difference, that the light's doing exactly what it does in a fiber optic cable. It's bouncing around before it gets transmitted. It doesn't transmit in a straight line. And if it was a straight line, it's a straight line full of electrons. And the electrons slow it down because they don't move as fast as light. So when the light hits the electron, it moves the electron a little bit, perturbates, creates a new photon. So every time it has to interact with an electron, it gets retarded in its progress. It's slowed down in the sense it takes time to move the electron and create the new photon. And that's all that's retarding the progress of the light. But the energy itself, the force, didn't slow down. The force is just being consumed by little traps of the electron that it has to get through. So you could think of it as little cul-de-sacs on the road, and you have to go into the cul-de-sac and come out, into the cul-de-sac and out. And you know that if a straight road had that and you were going 50 miles an hour, you know that, oh yeah, I wouldn't be going 50 miles an hour in actual accomplishment because I had to do all that extra distance in these little circles. So even though I was going the speed of light, I won't look like I'm going the speed of light because I'm getting slowed down in little circles. Not a complex understanding, explanation, perfectly rational explanations for these things. We don't need Thor. We don't need your gremlins. We don't need your magic hyperburloiding bullshit.
You think it slows down and speeds back up again, as modern science does, because that breaks.
That's not what they think. So again, it's just a lie. So again, just lie about the arguments other people make is one of the most, I mean, that just is the obvious, is when you've already lost the argument, is when you have to lie about what your opponents are saying, okay? And that's just a gross lie. That's not what physics says. You're the kind of guy who would shove a gopher up his poop chute. That's Neo. Oh, Neo says that. Neo, the magic Matrix character. Ooh. Your mother watched cartoons. Why she let the garbage man bang her. Fuck you. Die soon. Horribly.
The law of the conservation of energy. And like actually light leaving glass, it hits the gas and speeds up again. Well, that expenditure of energy is absolutely impossible. And then
right, again, it wouldn't be an expenditure of energy. Like I say, your foot would be on the same pedal. It didn't change anything. You just slow down, and then once your wheels get friction again, you can move. So no need for this speeding up nonsense. No conservation of energy violation. Just a lie. That's all it is. It's a frickin' lie. He just keeps lying.
To correctly understand light is a perturbation, which is light can only be, and light, of course, is a field modality. Obviously, Light is a field modality. We have
Obviously, it's not obvious at all. Your fields aren't obvious. There's no evidence of their existence. You know, it's not at all obvious. Not at all. Not even close to obvious. Not even you know, anywhere near it. Yeah, I have one of these blues, you know, the pod type, and they really are kind of easy to refill. You just pull the little bottom out. Yeah, a little messy. Okay, wiped it on my frickin', you know, posterity shirt. Shirt I should be cremated in, I guess. Anyway, yeah, I don't know. Might be better to get cremated naked or something. But anyway, I have to think about it some other time. But yeah, it's that easy. Just refill a little bit. Back in business.
electrical, magnetic, dielectric, and so-called gravity, which is nothing other than incoherent dielectric acceleration. But light is
incoherent. I'll agree with you there that gravity is the mixed force, the randomest force, the crudest of the forces. Magnetism is segregated for the polarization, the color, and a light is at a frequency. So they're all same forces, just different manifestations of exactly the same thing.
a field perturbation. So fields are only perturbations and propagations. There's nothing that is being transmitted by the strict denotation of the term.
Yeah, it's nothing by the strict denotation. Do we have to use the strict denotation? Is there any reason to do strict denotating? Why bother with that nonsense? It's clearly a transmission medium. Why are we? Why do we need to argue about it? You're saying it's this disturbance that travels through the medium. Okay, can we agree on that's what you're saying? Let's just have an understanding. Put it in words I can understand. I can understand you saying there's a disturbance and it travels through the medium, and this is the speed at which it travels through the medium. There, that can make some sense. But this crap you're spewing doesn't say that. You won't say that overtly, directly. You keep wanting to say, oh, it's a wave, but it's not waving. I mean, it's transdoing. It's all kinds of crap is happening. Well, then explain how this other crap is happening and how the other crap doesn't have a consequence.
Transmission, and there's nothing that's moving. Light does not move. The so-called speed of light is the rate of induction.
Again, some more just garbage. The light doesn't move. I mean, the inductiveness moves. So what's the difference? What's the difference?
Of the ether against itself. And I mean, and it doesn't matter if you call it dark.
So the ether against itself. Doesn't matter what you call it, dark matter. I mean, why would I call it that? I mean, ether is already a silly enough concept. Now you're going to fold dark matter into it. For what purpose? Why? Why would you take one of conventional physics's most obviously made up pieces of shit and sit there and try to turn that into a reality? Why sully yourself, soil yourself, essentially, smear their shit on your forehead? Why are you doing that? That's just so stupid. It just makes you look even dumber. You believe that the ancients had all the knowledge. Well, where did they ever talk about the dark matter, the invisible material stuff? I mean, the demons and the angels? It's dark matter angels?
Matter doesn't matter if you call it ether. It doesn't matter if you call it counter space. Because the one thing Mother Nature...
Well, it seems like you think it matters all these words you're so fucking anal about. I can't say the word transmission. I can't say the word wave. I can't say disturbance. That's not good enough. And then all of a sudden now I can say anything for the word, for the medium itself. The God of your whole theory, the medium, the ethery thing, I can call that anything. But everything else, I can't call anything. I can't call a photon a photon. I can't call quantum quantum. I can't call anything else anything. But the medium itself, yeah, I can call it booger space, and that's okay with you.
Sure does for certain, and she does not give a shit what stupid little idiot human beings.
Well, again, this whole talking like a fucking baby talk about what nature thinks and what nature does. Nature does, like nature's a person. Like nature's a god. Nature's nothing but fucking mechanical processes. That's all it is. It doesn't have a brain. It doesn't have a fucking opinion. This is all just religious goop.
It's called, you know, her or works. And this is not works in the sense of W-O-R-K-S, but W-E-R-K-S. I don't know if a lot of you understand the difference.
Yeah, no, I don't think I'd worry about that. Yeah, I don't think most of us worry about the spelling works with an E.
Between those two, I think a lot of you probably do. Works versus works. That's actually not a term used anymore today in the common English vernacular. But I think
nothing you say is common English vernacular in terms of denotating a fucking thing.
I actually brought that to full explanation because, like I said, all you have to do is understand the nature of light, which basically nobody does. Now you have to understand what the hell a polarizer is.
And you explained none of it. So it's 16 minutes into this video and you gave us nothing. Coaxial cable, perturbating interference, restorationer.
A pass filter. It's not.
So we're back to that crap again. No, they're all transmission filters, period. They filter what they transmit. Some stuff yes, some stuff no. That's the filter part.
A cut filter. Like I said, you could add all sorts of colored filters and they're going to cut the light down to zero, depending on how dense they are and how many you add. But polarization filters is actually the case. If you actually turn them.
And so all that means is you can control the density of the filter. That is how much, how often it filters, how likely it's going to filter a particular photon going through. So you can increase the likelihood of filtering.
In increments relative to 90 degrees. So if you actually take two filters, 1 second, 90 degrees relative to the first, and you can completely black out the light. If you actually introduce not only a third, a fourth, a fifth, and a sixth, the interesting thing, and it's not only interesting and paradoxical to people who understand what light is and what polar.
And you don't understand. I've explained exactly why that happens, because each filter is improving the polarization. And if you incrementally improve the polarization, you can go from this to this with only losing about 5%.
Polarization filter is it actually gets lighter. And literally, the more polarizers you add between the first two, the lighter it gets. It doesn't actually get like bright, 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 but I mean, it gets light.
Yeah, it gets as light as it started, which is 50%. You can't fix what the first filter does. So unless you put light into it that's 100% polarized in the correct direction, you will only get out of your filter, which, 50% of the light. But if you put in 100% polarized light, you can get out 95% of the light and change its polarization.
And lighter and lighter and lighter. And that blows people's minds, and that's why they call it a paradox.
Well, again, it's not a paradox. It shouldn't blow anybody's mind. It shouldn't even have been a controversy. It's so obvious what's taking place. It really is obvious what's taking place. You only need to put together 2 or 3 facts to figure out what's going on. Not that complicated, really.
Oh my God, the more filters I add after the 2 filters, which completely blacks out the light, makes it lighter. That doesn't make any sense.
It does if you understand the filter doesn't test for polarization. It creates polarization.
That's kind of like adding like a bucket of ink to some clean water, where it's murky, and then you add another bucket of ink to the same water, and it gets black. But then you add the exact same bucket of ink to the clean water, and it gets much clearer. And then you add at a certain angle,
it's nothing like that at all. It's a very precise thing that's taking place. It doesn't have anything to do with stains.
Kind of a crude analogy, but
no, irrelevant analogy, not directly or even tangentially properly connected. So it's not really an analogy at all. It's a false little fairy story, not connected at all.
Anyway, the polarization paradox is actually, from my perspective, it's extremely simple. But
yes, from your perspective, it's simple, but you can't draw it. You can't explain it in any kind of common terms. Instead, you have to talk about some kind of coaxial circuit that interferes with itself and then gets uninterfered by the other filter. And that's how it happens. And as somebody's supposed to know what the hell that gibberish was. What is that gibberish?
It makes absolutely no logical sense if you're steeply rooted in quantum atomism, and that's all quantum is.
No, if you're rooted in something called evidence and logic and sound reasoning and valid argumentation and the rules of logic, then this mush doesn't count as anything. This is just a fairy story. There's no evidence. There's no reasoning of a theory even. There's no even indication of a proof of concept, coaxial cable. There's no evidence of even the concept being reasonable. Nothing. You provide absolutely nothing but a fairy story where you might as well say the Gremlins did it. You've provided nothing.
Quantity, atomism. The ancient Greeks just...
Yes, right. They destroyed it. The ancient Greeks, who were shitting in their drinking water, knew what a quantum was, and they knew how much energy there was, and they knew how the energy was moving through the universe. No, they didn't. They thought the stars might be something to eat.
Destroyed atomism thousands of years ago, but we're rehashing that bullshit today. But that's all quantum mechanics is
yes, atomism just means that there's corpuscle, clumps, stuff that you don't need to bother cutting into pieces because it's just a clump of the same shit all the way through. It's just a clump moving. Oh my God, what an insane theory.
Rehash atomism. And number two, you have to understand what light is. You have to understand what different types of filters.
Yes, what you have to understand what light is, and if you have some kind of notion that it's a coaxial cable that somehow perturbates. Right, sure. Like I said, I mean, somebody telling me it's a running elf, you know, a flying elf makes more sense. I can envision a flying elf. I can't. Coaxial cables running from stars. No, sorry, makes no sense.
Sorry. This is also the reason why people will do, and I've had these calls, this is related to photography, people say, I use the polarizer or an ND filter on my camera to do like...
All right, so this has, again, nothing to do with how they work or explaining polarizing filters. Some dopey story about how some idiot ruined his camera with a polarizing filter.
Like a time exposure of a sunrise or sunset, like my sensor's burned, like the camera's destroyed. It's like, but when I looked at the camera, there was nothing there. You know the reason why? You know the reason why? Because all those sensors, doesn't matter what's a Sony or Panasonic or Tower Jazz, all those digital sensors and digital cameras are receptive, means the photosites on there, on the silicon wafer technology, is sensitive to a lot more than visible light.
Yes, but usually polarizing filters actually do block UV rays, so, you know, sort of doesn't make much sense that you ruined your camera. So it had to be a polarizing filter with no UV screen on it, I guess.
In other words, there's all sorts of frequencies of light that are passing through that really dark filter, and you thought that your sensor was not really... I made this mistake at a really early age, and I mean, this was really stupid. I used an infrared filter. It was really dark when I put it over an infrared light source, and, you know, it's just pitch black. You know, long before I understood what light was and different frequencies. I was really young, and this was...
Yeah, it's pitch black because infrared is infrared. That is, you can't see it. So when the stuff you're seeing is visible light, and it's not the infrared light. So that's what he got confused by, is that he thought the infrared was the same as the stuff you could see, when the infrared part was the part you couldn't see. So, but again, it doesn't have anything to do with polarization.
A stupid mistake. And I looked into that infrared. I got really close to it. It's a really bright light source, one of those big torches, you know, like, you know, it's zapping some serious, like, wah. But with that infrared filter over there, it was like pitch black. And I had my eyeballs up to it, like maybe 10 seconds of like this. Oh my God, my eyeballs were throbbing for a week afterwards. I couldn't see anything. It's the same thing with actual digital camera sensors. Just because you don't see it, don't mean it ain't there, because electromagnetic...
Actually, I don't think infrared light can actually get to your retina, so all you did was burn the surface of your eyeball.
Magnetic spectrum is wide and variegated. And interestingly enough, sensors inside digital cameras can see, even though they don't register on the photographs, they actually see a lot more than visible light. I mean, a lot, even with the IR.
They don't see a lot, actually. See, there's not a lot of that other kind of radiation. Actually, most of the radiation is visible light. It's most of it. Mostly.
Our pass filter in front of there, yeah, they see a lot more than visible light.
Right. So he just pointed out they have an infrared filter to block the infrared, but obviously not blocking that much, because that filter is just a piece of plastic and it would melt if all this infrared was going to burn it to pieces. So obviously there's not that much.
And that's how people destroy their cameras, by doing time exposures with like really dark ND or polarizer. Well, there's not much light passing in there. I thought I could do a 5-minute exposure of the sunrise. It's like, yeah, the thing is that your camera sensor is sensitive to more than just visible light. Anyway, this is the answer to, let me sip on some more of this really shitty coffee.
Yeah, well, it's a shitty video, so the coffee should shit too.
Your camera sensor is sensitive to a lot more than visible light. And that is the...
All right, so again, another completely mislabeled video. He explains nothing. Field theory explained in simple and light. In simple and light. I didn't even realize how poorly written it was. Paradox of field theory explained in simple and light. This was an explanation in simple. I'd hate to see the explanation in complicated.
The answer to the polarizer paradox. I hope I explained that simply.
No, you explained nothing about how the polarizer worked, how the other filter changed it. You just said it interfered and now it uninterfered. When I put the other filter in, it restored the interference thingy. It made interference, it restored interference, it double interfered, whatever, blah, 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 some kind of mush. Completely void of anything called explanation.
It's really hard to explain abstruse point.
Again, it's not abstruse. There's mechanical processes. Some of these things, these facts we know. Again, we know how the polarization filter is made. It's made of lines. Now explain how the lines affect the photons.
It's both metaphysics, but also field theory, because my mind thinks about that stuff all the time, and like I don't think anybody else's does. They're all like worried about bills and fan.
Yeah, well, whatever. There's lots of people who think about physics and think about process and how it might be improved, but apparently you're doing it based on a religious bias and prejudice that has you thinking in archaic Stone Age ways of making monkey cameras or something. Your phantasmagorical wacky verse that you think exists and runs everything. The wacky verse is in control.
And feeding the kids and the job and spot the dog, like wiping his butt on the carpet. And I don't have any of those.
Yes, you don't have any of those problems because you inherited a bunch of money and you just sit on your ass and buy cameras all day. Okay, got it. And get donations to buy some more cameras that nobody else can afford. Fine. And tell us how great they are. Yeah, great. I wish I had that gig.
Those concerns. So thank you so much for watching. If you like these videos, click the link below. Tell me to jump off a cliff, whatever makes you.
Yes, just do something like tell the truth for a change. Explain, reveal all of the stuff that doesn't support your theory that you've observed actually happening. Like when you just put a couple of LEDs in the ferrocell, how it completely changes its function. Yeah, well, how it completely illustrates its function, actually, and how its function is an illusion. Has nothing to do with revealing facts. It's a distortion of the reality, not a picture of reality.
Happy whatever tickles your pickle. Hasta luego, do swidania, and увидимся.
Yeah, whatever. Lickety flack. Yeah, something like that.
Girlfriend.
Whatever. No chance there, fella. All right. Ken uses Apple products. Who cares? Okay. The lawns are segregated by color. I don't know what that means. You're like the Lester Maddox of particle physics. I don't even know who that Lester asshole is, but I'm sure I'm nothing like him. So fuck you for that. Whatever that means. If I could possibly care. And such. All right. So I guess I'll just do a quick, maybe a comment. And we'll see if there's any other participants. Now you can change the subject if you like. I prefer you rag on Ken, but do what you feel like doing. All right, back to comments. All right, so the dude, he calls himself when he's not the other guy. He had to, because I did block him. So he post economic theory on my video, which is, really, it's a physics channel. That's really being rude. And so then he says, I mean, you know, it's people should be concerned with the horrible economic system we have, but it's not the subject of this channel. It is clear that Thomas Edison could not be credited with the invention of the electric light bulb. So this is what he's taking a quote from a website, like they know the truth, like they're the authority on what happened in history. They're the authority. Something called Julian Turbin. He's the authority. No, he's not. He's just another asshole with an opinion. With the light bulb, incandescent lamp. Well, again, nobody argued about whether it had to be incandescent or not. All people wanted was an electric light that worked. That's what Edison, it was talked about for years before Edison worked on it. Okay, I mean, he was sort of nagged about it because he sort of said years earlier, this is something we're going to have. It's going to happen. And then people sort of nagged him, well, where is it? We haven't got it yet. Why isn't it here? And then I think he was actually in between jobs. Like he had done the talking machine and gotten some money and blah, blah, blah. But he hadn't been making any money lately. And he decided, hey, this light bulb might be a good thing to get back to to make some money. So then he started doing the light bulb thing for a couple of years. And, but again, the fact that other people had already figured out that you could heat a filament, they already knew you could have Benjamin. Are you going to argue that Benjamin Franklin invented the light bulb because he made a key glow? So therefore he invented the light bulb? I mean, it's just stupid. I mean, clearly Edison made it work. Everybody knew of the concept that electricity creates photons. Everybody knew that. Nobody had been successful in turning those photons into some sort of thing you could practically produce, you know, without burning something to pieces. And Edison is the guy who figured out how to do it without burning something to pieces. And so this is just bullshit to sit there and play this game that we must acknowledge other people. When, no, the story is Edison made it happen. He did it. These other guys failed to do it. The Wright brothers, people talk about the Wright brothers. Nobody feels an obligation to talk about 900 other guys that jumped off of cliffs and almost flied. I mean, it just really sucks that you sit there and play this game like somehow I have to accept the Wright brothers didn't invent the airplane and this guy didn't do this and this guy didn't do that. Bull fucking shit. Just crap. So fuck off with that shit. All right, enough of that. Oh, people, truthers. So anyway, so give you a couple of minutes, see if anybody's got anything to say that's reasonable. And if not, we'll just move on to something else next time and such. I read the Ken questions, right? Yeah, well, I actually wrote down the question, you know, what causes the perturbation, no, the disturbance called a photon. So I wrote that before I saw that video because he doesn't answer this question. What causes the disturbance? Saying it's a coaxial cable doesn't explain what causes it. It's useless gibberish. What do you say an atom looks like? That'd be another thing. Just for him to draw a picture of what he thinks. What's in an atom, Ken? What is it? If nothing's real, are they just perturbation, proton perturbations, and electron perturbation? And what's perturbating? What's doing? Is there's nothing that's a something? Yeah. So, but you know, we'll get no answers. Yes, McCool CS. Yes, your message showed up. Your test was successful. I don't know why it was successful, but I guess it was. You'll no doubt earn a get the hell out of here quick enough. So I'll sit in waiting position for a moment, take a little break, and see if anybody has something to say. Give you a minute. And then we'll move on. Might as well open the drawing. Ah, the wonderful polarization drawing. Yes, very nice. Sorry, it's a little green. It really shouldn't be green, but very difficult to get these settings quite right. Let's see, it's probably the, yeah. See, once you make these windows, you know, stay on top, then they just get in your way. It's just kind of, yeah. So I can't even get this settings to stay on top. Bring the brightness up a little. Oh, wrong one. All right, never mind then. Too much trouble. But it's nice to have both cameras working without it catastrophically ruining the computer. All right, running out of time here, people. Let's see, that should be the right window. Let's see how many people are in here. 13. Yeah, well, we should get some action. Come on, somebody can say something reasonable, can't you? Oh, no, hiccups. Shit. Ah, looks like there's a comment that's being blocked. Nope, sorry, nothing. All right, then. Well, it looks like I've done my job here. So, till the next time and such, so forth and whatnot.